Okay, welcome back, everybody. Welcome to Tuesday's AP Computer Science A live lesson. My name is Rob Schultz. I teach at Bellbrook High School in Bellbrook, Ohio.
And I'm Jill Westerland from Hoover High School in Hoover, Alabama. We're so glad that you're with us today for a lesson you're going to love. I'm excited myself about today's lesson. So here's our map. Find yourself. You're somewhere here, and feel a part of our group and our community, and join us in challenging ourselves to be pursuers of Java. So before we go further into the lesson, let's review quickly your exam. It'll be May the 15th. You're going to have two questions. The first one will either be an array or an array list question. You'll have 25 minutes. And then the second question will be methods and control structures, and you'll have 15 minutes, and then 5 minutes on the end of each one to upload. And you can see that there's a makeup date if you have a special circumstance. And then for all the information related to the exam, please go to AP Central Coronavirus Updates and read everything that College Board is telling you about your test this year. We'll talk more about it, especially next week. So, please keep watching for more details. So today we're continuing on in array list week. We're going to talk about sorting. Yesterday I got so into my array list explaining in my extravaganza section that I just kind of left you with the code for the linear search. We've done that before. Linear search, you remember, is just like Control F. I'm going to start at the beginning of something and I'm going to search each item until I find what I'm looking for, if I find it. Today, you're going to talk about sorting, which is putting things in order, kind of like what you should be doing if you're helping your parents with the laundry. You should be sorting the laundry by what type before you begin to start washing things.
Thanks, Mom.
I know, unless you're Eric Westerland, my husband, and if it's dirty, that makes a group. That is the sort. So, I give him fits about that. But today, you're going to learn proper ways of sorting digitally, and tomorrow we're going to do a free response. So our analogy, and we're going to kind of unpack the lane that we're in. Imagine that Java is, huge. You know that it is. And we are swimming in a pool with lanes. And this week we're in the lane for array list. And that may cause us to be doing other things. We're not doing a ton with strings this week. We did a lot with strings last week. Strings will come up in small ways, not so much the string class. You're not going to see a lot of that this week. Now, please be taking notes. You probably could use a piece of paper and a pencil today. Mr. Schultz is going to demonstrate a lot of things to you, and hopefully you'll rewatch the video, of course, but you may want to begin to grab something to write with, and he's going to sort of take you off into that last array list that I left you with, which was the cards and the card deck. And here we go.
Okay, so I am excited about today too. Today is going to be fun. As we said yesterday, we're kind of thinking of this as game week in addition to array list week, and we're going to look at different things we can do, different game-related like little programs that we can do. So some prior knowledge that would be helpful, knowing how to instantiate an array list and knowing how to use just the basic AP subset, at least array list methods. So if you aren't comfortable with those, you might want to go back and watch some of the videos that we did earlier in this process, just for a little bit of familiarity with that. Today, what we're going to learn to do is we're going to learn to add an object to an array list. We're going to use loops to add multiple objects to an array list. We're going to use add, remove, get, and set to move objects between array lists. And then I know the main topic of today is supposed to be sorting. And if you've watched past videos, we've already covered merge sort and insertion sort. Today, we're going to look at selection sort. So we'll be careful with time, I promise, today, because there's a lot I want to throw in here, but I want to make sure we've got time to get to selection sort in the end. So today is, like I said, we're looking at a game theme, and the main focus today is going to be working with cards. Okay, so I have my little deck of cards here so that we can kind of demonstrate some things as we go. But I created, and Mrs. Westerland showed you a version of this yesterday, so that we have a card class to play with. I created a basic card class that has two instance variables, a string that'll contain the suit and an int to contain the value. We have a constructor that we can pass a string and a value in to create a card object. And then we've got a couple of getters, so we can get the value, we can get the suit, and then we also have a toString method. So in our client, if I have this code, and notice there's nothing magic about the suit, you know, we could do the traditional hearts, diamonds, spades, clubs, or I could have dogs, cats, fish, birds. I could have unicorns, dragons. I mean, I could throw in whatever I want for the suit. Okay. So when we create a couple of card objects and we call print line, it's going to display the 2 strings. So our first one will display 5 of hearts, and the second one will display 8 of dogs. Okay. So that's the basic card class we're going to be using for the next few days, actually through the end of the week, with some of the little card games we're going to program and take a look at. Okay, so here are our goals for the day. Now, here's what we're going to do, but then behind the scenes, this is in terms of Java, what we're really going to do. Okay, so the first thing is going to be just to make a playing card. Well, in Java terms, that's instantiate a card object. Okay, we're going to make a single suit deck of cards, which means we're going to use a for loop to create an array list of card objects. And to make a multi-suit deck of cards, so like a traditional deck where we've got 4 different suits, we're going to use nested for loops to create an array list of card objects. We're going to shuffle the deck of cards. So we're going to use the array list methods to manipulate card objects in an array list. We're going to deal cards to 2 players. So these are really all of the things that we would do for any card game. You know, we have to shuffle the deck and we have to deal the cards. And then, as Mrs. Westerland said yesterday, in certain games, it helps if the cards you're holding in your hand are sorted. So that's when we'll get to our selection sort algorithm, and we'll use selection sort to sort the cards in each player's hand. Okay, so here's the fun part. Let's go to our live demo, and we're going to start doing some coding. Okay, so I'm going to switch over to JGrasp. Hopefully you can see that okay.
Yeah,
Move
that's good.
that little thing out of the way. So I have a folder that I've created in JGrasp that's just for today's stuff. As Mrs. Westerland said yesterday, if you're using JGrasp, we want the different files that go together in the same place so that everything is available and can be referenced together. So I have my card class. And I also have this little card tester that I kind of cheated and went ahead and worked ahead on a little bit to kind of prep things for a couple reasons. I mean, first off, I wanted to save time and not have to type all of the skeleton of the code in. I also wanted to give myself some little reminders so I didn't forget things. So I've got all of the goals kind of laid out here. But I also created this little method at the bottom just to save some time. So the purpose of this display deck method is to allow me to pass any deck of card objects into it, any array list of card objects, and it's just going to traverse the array list and then display whatever card it's looking at as it traverses the list. So that way, as we're going through each one of these little goals, I can call that method as opposed to have to retype the code to do all that. So, okay, so if I compile this and run it, we'll compile and run. There we go. It should just come up and tell me what all of my goals are at this point. So if I scroll up a little bit, so we haven't really done anything yet other than just display our goals. So we're going to go to each one of these. Actually, I think I'm going to go through and I'm going to kind of turn all of these off. I learned this earlier. I guess last week is when I learned that you could do that. I had no idea that you could do that. We're just going to create a couple of card objects. So card C1 equals new card. And I think we had said that we were going to make this one a heart and a 5, and then card C2 equals new card dog, comma 8. And then I'm just going to display both cards. So we don't need to call our deck class yet. We haven't created an array list yet, but system. I can't type and talk at the same time. So we're going to print line C1 and print line C2. Okay, so now I'm going to recompile and rerun. And as you can see, we have under our goal of make a playing card, we've got the 5 of hearts and the 8 of dogs. So everything's working the way it's supposed to. One of the things we're going to focus on, so I'm going to comment this one out. One of the things we're going to focus on Friday is using data to test your code and make sure that everything works the way it's supposed to. So I always recommend to my students, as we're working on something that has multiple steps to it, take the time to stop and test it as you go. Let's see, we can undo this one, uncomment. Okay, so now we're looking at goal number 2. We want to make a single suit deck of cards. So here's how this is going to work. We're going to create a loop. Well, first off, we have to create a deck. So array list, it's going to be of type card, so it can contain card objects. We'll call it deck1 equals new array list. Okay, so we have created a deck, but at this point there are no cards in it. And it would be pretty tedious to have to go through and create. Let's say I'm doing a rook deck where we have different suits, red, what was it? Red, yellow,
Green and black.
green, and black. Okay, so
56
it would be
cards.
fairly tedious to have to go through and write 14 lines to individually create 14 cards the way I did up here with our first goal. So we're going to use a for loop. Int I equals 0. I'm going to call it counter just so it makes a little more sense what I'm doing. Count is less than 14. In fact, our values are going to go from 1 up to 14. So I'm going to go from 1 up to 14, and we're going to do count plus plus. Okay, and I'm going to say that I want deck 1 to add a new card. And I'm going to say that this is going to be a red. So we're going to do the red suit. And in this place, I'm just going to insert count. Okay, and this is where that display deck comes in handy, because now if I want to display my deck when I'm done, all I have to do is say display deck and pass in deck 1, and it should display the entire deck for us. So let's test. Hopefully I'm right. Oops, what did I forget? I always forget that second parenthesis. I'm going to do that. I guarantee I'll do that.
For that. Why don't I check for that?
That's okay. I got to learn. The only way I'm going to learn is to see the mistakes.
8 eyes between us, including our glasses.
Okay, so for deck, whoops, I went too far. There we go. So for goal 2, make a single suit deck of cards. We have the 1 of reds, the 2 of reds, the 3 of reds, all the way down to the 14 of reds. So everything right now is working the way it's supposed to. Okay. So I'm going to keep kind of turning these off and turning them back on as we work our way through. So I'm going to comment this one out. There it is. And I'm going to uncomment goal 3. And I just realized Control-Shift/. I'm going to try that. I haven't tried that yet. So see if I can. Oh, looky there. Okay.
Look at that.
Okay, so so now we're going to make a multi-suit deck of cards. Okay, so we need to create another array list of cards. We'll call this one deck 2, and then deck 2 is what we use throughout the rest. So array list card deck 2 equals new array list of cards. Okay, and in this case, I also need to identify some suits. So this is where we start playing a little bit, and we have a little bit of crossover between some of the different topics that we've looked at. We're going to create an array of strings called suits. And we can actually, I'm going to do it this way. I'm going to use an initializer list. So we can put in as many suits as we want. Do we want to keep with colors, or do we want to do animals this time?
I did mine with colors that I could share at the end of class. So if you want to do something different, I can throw my code in with the colors.
All right, we'll do dog, cat, fish, and bird. I mean, like I said, we could do the traditional clubs, spades, diamonds, hearts, but this
why
is more
be
fun.
Plain when we can be fun and fancy?
And again, there's nothing magic about the fact we have 4 suits. You know, we could do an old maid deck where we could have 26 different suits, and each suit only has 2 cards, right? So we could do as many different suits as we want. I'm going to stick to 4 just to kind of keep things from getting too out of hand here. So now we're going to use nested for loops to create a multi-deck, a multi-suit deck of cards. So first thing I'm going to do is I'm going to and we can even kind of adjust and use for loops and for each loop. So I'm going to say for string S in suits. So for every suit in suit, now we're going to go through and do for, what do I want to do? Int count equals 1. Count is less than or equal to 14. Count plus plus.
Yeah, this mimics above.
Okay, and then we're going to say deck2.add. In this case, we're going to say S. So we're going to pick whatever suit the current suit is, and then add whatever value we have. Okay, and again, when we finish with this whole thing, we'll display the deck. So display deck, deck 2. Okay, let me make sure I didn't miss any of my second parentheses anywhere.
I don't see any.
Looks like we're okay. All right, so let's see. I'm going to clear our space down here. That'll help a little bit too. and then we'll rerun. Oops, what did I do?
It's
Oh, whoops.
new card. Yeah, new card.
Yeah, that's what I did.
And then the second set of parentheses.
Yeah, thank you. See, it's always something having to do with that second set of
Oh,
parentheses.
no.
Okay, there we go.
This probably never happens to any of you students out there, does it? Just us. Just kidding.
So as I work my way through, so now notice we've got 14 cards that are in the dog suit. We've got 14 cards that are in the cat suit. We've got 14 cards that are in the fish suit.
Fishes.
Yeah, and I've got 14 cards that are in the bird suit. Okay, so hopefully with that you can kind of see the different ways that we can create multiple decks of cards. And again, I can put as many different suits. I can adjust the values. I could do duplicate decks of cards. If you're playing a card game that uses 2 decks, we could wrap all this into another for loop that repeats twice, or for however many decks of cards we want to include. So it's going to create a multi-suit deck, and then it'll add another multi-suit deck onto the end of that, and a multi-suit deck. So there are a lot of ways that we can create array lists of card objects, okay, depending on what game it is we're trying to play. Okay, so let's see. So now I'm going to comment just this part out because we want to create deck 2, but then we're going to come down and we're going to uncomment the basic shuffle part. Control Shift, whoops, slash, there we go. Okay, so for a basic shuffle, notice I have my deck of cards and I want to shuffle my deck. So right now everything is sorted. Okay, this is as if they're right out of the box. Here's how a basic shuffle works. Okay, at least in Java programming. A basic shuffle, at least my definition of a basic shuffle, is where I randomly pick a card, okay, and I just stick it on top of the deck. And then I pick another random card from somewhere and I put it on top of the deck, okay? And granted, if I were doing that shuffling by hand to play a card game, that would take forever. But it's very easy for the computer to do that 500 times, 1,000 times, 10,000 times, and we end up with something that looks kind of like this. So all I'm going to do, I'll start by just doing it once. I'm going to say that we want to add a card that we're going to remove. So I'm going to say deck2.add. We're going to add it to position 0, which is the top of our deck. But the card that I'm going to add is actually going to be a card that I remove from a random location. And if you remember, we talked about how to find a random location within our deck. Math.random times deck2.size. Okay, so let's see, let's make sure I'm not going to miss any parentheses in here anywhere. Yep, see, I almost forgot another one. Okay, so let's kind of unpack what this line does. Okay, first thing we're going to do is we're going to find a random number. Remember, math.random gives us a value from 0 up to, but not including 1. Okay, so I'm going to get from 0 up to 0.9999999. If I multiply by the size of my deck, let's say we have 52 cards in our deck, or in this case, we've got 14, 28, 56 cards in our deck. So I'm multiplying by 56. That's going to give me a value from 0 up to 55.9999999. Okay, then we're going to cast that as an integer, which is going to give us an integer between 0 up to and including 56. We're going to remove whatever card is at that location, and we're going to add it back at position 0. So if you take a look at what we end up with, display deck, we're going to end up with something, clear this again, that looks like this. Okay, so everything looks the same, but notice that when we get up here to the top, we've randomly removed the 9 of fishes. So 9 of fishes is no longer down here. It's now up at the top. Well, again, it would take us a long time to do that by hand. But the nice thing about working in Java is that, oops, what happened? There we go. I can go in and very easily say for int count equals 0. Count is less than 10,000. Count plus plus. And I can say, okay, we're going to repeat that action, randomly picking a card and putting it back into the deck 10,000 times.
You're going to need a bracket at the end of.
Oh, yep.
Right
sorry.
there. Yeah.
Sloppy coding.
No, you're good.
Okay, so now notice this is what our deck looks like, and it's pretty well shuffled.
10,000 times.
10,000 times. So 10,000 times we took a card from a random point in the deck and put it on top, grab the next one, put it on top, grab the next one, put it on top, grab the next one, put it on top. Okay. And we could go even more than that. You know, we could go 100,000 times or 1,000,000 times. I mean, whatever it is that you feel like you'd be satisfied that it's shuffled. Okay. So that is that's our random shuffle. And I'll be honest with you, for my card games that I like to play, that's usually pretty sufficient. Okay, that works out pretty well. I'm going to put my 2 cards that I pulled out back, and we're going to see if I can do a perfect shuffle. Okay, so if you, and I'm going to comment this part out because I don't want to shuffle it and then use the perfect shuffle. So we're going to comment all this. Okay, so if you've looked at, by some chance, if you've looked at the 11s lab, one of the things in the 11s lab they talk about is a perfect shuffle. And I'm going to move my camera down a little bit because I can't do this holding the cards up in the air. I need to hold them on the table. I realized I don't have a document camera that's as cool as the one that Mrs. Westerland has, but I do have my little camera that I can at least tilt down and show the table. So, okay, so when we talk about doing a perfect shuffle, okay, what we end up doing is we cut the card deck exactly in half for it to be a perfect shuffle. So I have, in this deck of cards, there are 52 cards. I have 26 in this hand, 26 in this hand. And to do a perfect shuffle, I'll see if I can do this. What that means is we're doing 1 card, and then 1 card, and 1 card, 1 card, and I can already tell I've messed it up. But we try and alternate 1 card all the way down through, so that if we did this correctly, we would have, you know, the ace, ace, 2, 2, 3, 3. Hey, I didn't do too bad. 4, 4, 5, 5, 6, 6, 7, 7. Whoops, 8, 8. I don't know if you can see those or not.
That's cool.
So that's kind of the idea of a perfect shuffle. Yeah, I kind of messed up in there a little bit, but okay. So the next type of shuffle we're going to try and do, and again, I got to be careful with my time. We're going to try and do a perfect shuffle. Okay. So here's the idea behind the perfect shuffle.
You may want to switch your camera back up.
Oh,
I mean,
yeah. Thank you.
I mean, you know, just because, even though it'd be fun to watch you type so fast, but still.
I don't know. Okay, so here's the idea behind a perfect shuffle. And for the sake of time, I'm going to use my cheat sheet here a little bit. Okay, yeah, I can already feel time getting away from us. It's 4:23.
23, yeah.
Okay, we're doing
20
okay.
minutes.
Okay, so for our perfect shuffle, first thing we have to do is we're going to create a temporary deck. So when I did the perfect shuffle, I just kind of picked up the deck and shuffled it back together. We're going to create a temporary deck of cards, array list card, temp deck. Okay, so what's going to happen is I'm essentially going to take the deck and split it kind of virtually in half. So you can kind of picture it as 2 halves. And I'm going to take the card off of the top and put it in my temporary deck. And then I'm going to take the card off the top of the other side, put it in the temporary deck. And then I'm going to kind of alternate between the deck on the left, the deck on the right, or I guess you could think of it as the top part of the deck and the lower part of the deck. So let's see. So while deck2.size is greater than 0. So while we still have cards in deck 2, I'm basically going to remove the cards from deck 2 and put them in this temporary deck because, again, they're physical objects. So in this case, we're going to actually remove an object from one deck and put it into another deck. So as long as there are more cards in the deck, we are going to move from one deck to the other. Now, here's the thing. It would be really easy to say inside our while loop, just take whatever card is at position 0, take whatever card is at the halfway point and move them. We're kind of assuming that we have an even number of cards. But again, because we could go back and change that and do, 5 suits or, 5 cards per suit, we could have an odd number. And if we try and remove a card from the deck, assuming that there's an even number, but there's an odd number, that means we're going to go out of bounds at some point. We're going to end up throwing an exception. So trying to think whether that would be a null pointer exception or an index out of bounds exception. I guess it would be a null pointer exception. We would try and reference something that's not there. So, so what we have to do is we have to make sure as we go through our deck, we're only looking at 1 card at a time. So the easiest way to do that is to base it on the number of separate piles I have. So the way I've got mine set up, if deck2.size modulo 2, remember modulo gives us a remainder of, if I divide by 2, we're going to say if it's not equal to 0, then we're going to add the card from the top of the deck. Deck 2, remove deck 2. Whoops, no, I said we're from the top of the deck. So we're going to take the card from position 0, we're going to remove it, and we're going to stick it into our temp deck. Okay.
You're going to need a K up there on line 52, 4.
Oh, thank you.
Yeah.
You should come over and like watch me code all the time. You'd save me a lot of time.
It's cool. It's like watching people cook on the cooking channel. It's fabulous.
Yeah. Well, like I said, I feel like this is kind of my Bob Ross moment. We're going to put a happy little if statement, and you know, happy.
We don't have happy little trees. We have happy little methods.
If you've never watched Bob Ross when he paints and he cleans his brushes, he starts beating the brushes on something. He always says, "Yeah, I love beating the devil out of my brushes." So yeah, that's kind of funny. Okay, so the way this is going to work is we're going to take the size of our deck, and if the size of our deck is odd, we're going to remove the card on the top and put it into our temp deck. If it's even, I'm going to keep it so it makes more sense. If it's even, we're going to remove the card at the top. If it's odd, we're going to remove the halfway point. Okay, it doesn't really matter one way or the other. I'm just being picky. Okay, so now when I do this, and we're going to do this as long as we have cards left in the deck. Okay, and then what we have to do is after we've taken a card, 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 we're going to kind of layer them. Then we have to put everything back into our deck again. And we can't, even though we're using references, we can't just say deck equals temp deck, because then we're kind of taking both decks and phasing them together. So again, we're looking at 2 separate decks of cards. We need to take the cards out of one deck, put them into the other deck. So while temp deck dot size is greater than 0, we have to take the cards out and put them back into our deck again. So deck dot add temp deck dot get position, remove position 0. Okay, so now that I've taken all of the cards and I've put them into this temporary deck, I need to take the cards one at a time and put them back into my deck in sorted order.
Put it in deck 2 back there on the beginning.
Thank you.
Yeah.
Okay, and then we're going to display deck 2. Okay, so let's see. Here we go. We'll go for it. Hope I didn't miss anything.
I bet you didn't.
Second parenthesis. Okay. All right, so watch what happens with this deck when we run it. Okay, so now notice we had our deck. Oops, let me bump this up a little bit so we can see better. Okay, so we had our deck, and it was originally dogs, cats, fishes, birds. Well, I took a dog and a fish, a dog and a fish, dog and a fish, and then we get cats and birds, cats and birds, cats and birds. Okay, so that's just going through our perfect shuffle one time. So that's why when you see somebody playing cards, shuffle a deck of cards, you know, they'll try and do the perfect shuffle like that, and then they'll do it again. And they'll do it again, and they'll repeat, and they'll repeat, and they'll repeat, because just doing the perfect shuffle once doesn't really do a lot to shuffle the deck. So the other thing we have to do if we're going to try this perfect shuffle is we have to take all of this stuff and we say, okay, let's make sure we do that plenty of times. So for int count equals 0, count is less than 50, count plus plus. Okay, so now we're going to do that perfect shuffle, but we're going to repeat it 50 times, and we'll see what that looks like. Now, like I said, if you've done the 11s lab, there's some analysis that is done as part of that lab to see if that really shuffles the deck, because I don't want to give too much away about that lab, but there's a point where if you do a perfect shuffle and then you do another exactly perfect shuffle and another exactly perfect shuffle, eventually, because of the way you're picking the cards and putting them together, you're going to end up putting the cards right back into the exact same order again. So so there's some discussion of, okay, how many times do you have to do that before the cards are perfectly in the order that you started in? But you can see there is a little bit of a pattern here. You can see that things are shuffled up a little bit more. You know, like I said, me personally, I prefer just this basic shuffle. I feel like that's a little more random when we're doing cards. Okay. Okay, so that is our perfect shuffle. So we're going to leave that one active as well. So at this point now we've created a deck of cards. We have shuffled the deck of cards. I am going to comment this out so we don't see the shuffled deck of cards every time. And we're going to deal the cards to, we're going to assume we have 2 players. Okay, so Control-Shift/. So again, this really kind of works exactly the way the start of our perfect shuffle did. We're going to create an array list of cards. Actually, I'm just going to use the same one I had. Temp, what did I call it? Temp deck. Okay, we're going to say we're going to go back to temp deck. I don't even need to redeclare it. We're going to go back and we're going to say that kind of the same thing we did before. While I have cards in deck 2, deck2.size is greater than 0. We're going to use kind of that same little algorithm we did before. If deck.size modulo 2 equals 0, we're going to take the top card off of the deck. Oh, this is what we needed. I knew we needed an array list for something. I just couldn't remember what. We're going to create player 1 hand. And player 2 hand. And if we were playing a game that involved 4 players, we would add player 4 hand and player 3 hand. Okay, so now I have 2 separate array lists, one for the cards that player 1's holding, one for the cards that player 2's holding. So we're going to say that we want to shuffle and deal all of the cards. If I only wanted to deal 5 cards to each player instead of a while loop, I would use a for loop where we could say, okay, let's give 5 cards to each player, 7 cards, whatever it is we need for the game we're playing. But we're going to say that, again, because we're kind of doing a war game and some different things like that later, we're going to say we're going to shuffle all the cards. So if the size of our deck is even, at this particular time, we're going to give the card to player 1. So we're going to remove a card from deck 2, from the top of deck 2, and add it to player 1's deck. Otherwise, we're going to add it to player 2's hand, deck 2. So let's do this so that we can kind of see the different decks. So print line, player 1 hand, display deck. Okay, and again, because I can pass in any array list of cards I want, we can just tell it to display player 1's hand. Add a little extra line in there. We'll add an extra happy little line in there.
That's right. This is your homework, guys, by the way, is to make a deck and deal some cards to some players. So
okay, so yeah, I'm kind of giving away the answers.
That's
homework,
okay. I
but
just took a picture of this code because this is where I am in building my Go Fish game.
Okay, so so we have shuffled our deck. I forgot to tell it to clear. Here we go. Okay, so we're making a multi-suit deck of cards. Perfect shuffle. I forgot to clear those out. So we've got player 1's hand. So player 1 now has a hand of cards. Player 2 has a hand of cards. So we've basically just passed the cards to both players. Okay, and then we still doing okay time-wise? Yeah, we're doing okay.
Yes, we have. Yeah.
Okay, so last thing we want to do is we want to do our selection sort. Okay, so I'm going to add that because again, we might want to sort different groups of cards, and because this is something that we might want to apply to different lists, just like our display deck, I'm going to add it as a little method down here at the bottom so that we can call selection sort on whatever cards we want without having to copy paste code. So static void selection sort. I want an array list of cards. We'll call this D for deck as well. I'm going to jump over to here real quick. I'm going to go back to our PowerPoint just so I can kind of quickly show what selection sort does for those that aren't familiar with selection sort. I want you to think about the fact that I've got 5 cards that I want to sort. Okay, so I'm going to walk you just quickly through the algorithm for selection sort. Selection sort is it's an algorithm that requires that we traverse our array or our array list, depending on what it is we're sorting. So we're going to traverse the array list. whatever our current element is, we're going to mark that as the minimum value and the minimum location. So we're going to say that as of right now, our minimum value is 5 and it's at position 0. Then from there, we're going to traverse the remaining elements of the array list. So notice I've got nested loops. Okay, I've got a loop that's going to traverse the array list. I've got another one that's going to traverse the remaining elements. So I'm going to work my way through, and if at any time I find a value, if I discover one that's less than the minimum value, so in this case, 1 is less than 5, it becomes our new minimum value. I'm selecting the smallest, and we're going to continue to traverse the remaining elements. And once we get to the end, then we're going to say, okay, we need to swap whatever our current element is with whatever element we've identified as the smallest. So 1 and 5 trade places. We're at the bottom of our loop, so we come back up to the top of this outermost loop where we're traversing our array list, and now we set the current element to the minimum value again, and we're going to work our way through, and we're going to select the smallest. So traverse, traverse, and if we find a value that's less than our minimum, then it becomes the new minimum value. We don't have anywhere else to go as far as this inner loop is concerned, so we're going to swap the current element with our minimum value. So 2 and 3 trade places. And now we're going to kind of continue through this process. We set our current element to the minimum value location. We traverse, and every time we find a value that's less than the minimum, it becomes the minimum. So notice now 3 is less than 4, so 3 becomes the minimum. And by the end, we have selected the smallest value that's remaining in our array or array list, and we swap. So 3 and 5 trade spots. So now we traverse, we hit 4, we set the current element to the minimum, we go through. Notice we haven't found anything smaller than 4, but we still hit that swap. So essentially it's going to swap with itself. And then by the time we hit the end of our array list, everything is in sorted order. So that's how our selection sort's going to work for us. Okay, so let's go back to our live demo. I'm going to jump back over here. We started our little method down here. So I'm going to work my way through. So we said first thing is we've got to traverse our array list. And because we need to make sure we save some space at the end, I'm going to go from 0 up to size -1. I plus plus. Okay. We said that we wanted to select whatever our current value is and set that as our minimum value and our minimum location. So int min val equals d.getI.get. Remember those two getter methods that we had in our card class? Well, this is where we're going to use those. So get value. So that's going to give us our current lowest value. And then we also need to define where it is. So int min location equals I. So we're starting out by saying whatever it is we're looking at, that's our lowest value, and that's our lowest location. Okay. So then we said we need to traverse the rest of the array list. So for int j equals I plus 1, we don't want to go back to 0 again. J is less than d dot size, j plus plus. Okay. And we said if at any point the value that we're looking at is less than our minimum, so d dot get j dot get value is less than min. Anytime we find anything less than min, it becomes the new min. So min val will become our dec get whatever's in position j, whoops, dot get value. And the location will become j. Okay, and then we said once we get out of that loop, then we have to do a little swap. So I'm even going to put a little comment here, swap, not swamp. Swap. Okay, so we're going to create, if you aren't familiar with the swap algorithm, it basically is like a little juggling act. I'm going to take whatever's in the first position and move it to a temporary spot. I'm going to take whatever's in the second position, put it in the first position, and I'm going to take whatever's in that temporary spot and move it back. So we're going to create a little card called temp equals d dot get I. So that's our current value. We're going to set whatever's in position I to d dot get whatever's in our minimum location. And then I'm going to use set again and set whatever's in our minimum location to temp. Okay, so that's our little juggling routine. And that'll be the end of our loop. And that'll be the end of our methods.
Check the end of line 103 where it says min. I think it should be min val, but it might be min.
Oh, yep, you're right.
Yeah.
Thank you.
There you go. You're welcome.
Okay. Cross your fingers. Let's compile. Did I miss anything?
No, nope. You did not, rock star.
Well, you were watching over my shoulder. You helped me. Okay, so here's how we're going to check this one out. So for sorting each player's hand, and I'm going to leave those upper ones turned on. Okay, so we are going to tell it we want to do a selection sort on player 1's hand. And then we're going to display it. Let's see. We're down to 5 minutes. I got to type fast.
Nah, you're good. Nobody's going anywhere because this is so fun to watch.
That's true. Well, I thought you were going to say because at this point nobody really has any place to go, but.
Well, no, we have the couch, the refrigerator.
Well,
we have
that's
lots of
true.
places, but we have to
That's
see what
true.
happens. Do the fish and birds and cats and dogs go back in proper order?
Now, I'm glad you brought that up because I kind of kept this as simple selection sort. Notice it's only sorting on values, so it's not going to
it's
put
going to be
within
numbers.
colors. So that's actually something I was going to add. Oh, and I forgot to tell it to do selection sort for player 2's hand. So that was actually going to be something that I was going to add as a little add-on to the homework assignment, is to go back and edit my selection sort so it sorts by color first, and then it goes through and sorts by number so that you've got everything sorted and organized. Okay, so let's see. We are going to, I think that'll be okay. We'll go with it. I think it's going to have a couple extra little things printed at the top that I didn't turn off, but that's okay. Okay, so when we run, it is going to go through and starting at the top. Tell you what, I'm going to clear it and rerun it. Be easier to find the top that way. So I accidentally left a couple of the extra goals turned on, but we told it to deal the cards after being shuffled to the players. So notice they are not in order for player 1 or player 2. But then I told it to do selection sort. So now once I've done selection sort and I show player 1's hand sorted, notice we've got the 1s, the 2s, the 3s, the 4s. So they're in order by value. They're not necessarily in order by suit, but we've sorted all the cards by value. So now I've got my 1s, my 2s, my 3s, my 4s, my 5s, my 6s, 7s, 8s, all the way up through 14s together. So our selection sort did what we told it to.
Yeah.
It's probably not as complete as it should be, because I know when I play cards, we've been playing a lot of cards at our house lately too. I'll have to teach you how to play sevens sometime. That's our new favorite game. But you know, we sort by suit and then we sort by value within suit. So that's kind of the add-on for your homework assignment tonight.
You'll
Play
need
with
a
my
nested
selection
loop.
sort and see if you can make it a little better. And wow, that was a lot of stuff
I
to
know,
cover in
that
a
was so
short
great.
period of time.
We need the sound effect for applause. That was fantastic.
Oh, thank you.
Yes.
Okay, so our debrief and summary. First off, array list methods, and this is a pretty brief debrief and summary considering everything we just did. But main takeaways are that the array list methods, add, remove, get, and set, can be used to manipulate elements in an array list in a lot of ways. Okay, and the other thing I wanted to make sure to point out: selection sorted is an iterative sorting algorithm used to sort elements in an array list or an array. You know, we've talked about recursive algorithms for sorting in the past. This is an iterative sorting algorithm. So those are our debriefs for today. All right, there you go. I will pass things over to you for our tip of the day.
Very good.
Hey,
Okay,
thanks.
so make sure you come back tomorrow. Tomorrow we're going to take a little segue from the game, but I'm going to talk about your homework first. And this goes along with your tip of the day. Using cards in this way will force you to use, and you can see, we watched Mr. Schultz today. You're going to be using every single one of the JQR array list methods to manipulate your cards. And hopefully it's entertaining and fun. And I want you to start kind of thinking about what kind of games can I make with this. We're going to show you on Thursday some games, and I'm going to talk to you about some others that you might could make. So your homework for tonight is build your own deck. You can have it whatever you want it to be, and populate it with cards and numbers and values. And if you're into some of these, you know, role-playing games that have particular kinds of cards, I don't know enough to talk about it, but I know students I have them. Make your cards about those things, and deal cards to your players. And you've got plenty of information to do that. So that's your homework, and it'll force you to use the JQR. You got resources also. Shuffle your deck, you know, same thing. Essentially just kind of use it. We hope you engage with this, and I hope you built some arrays from the things I showed you yesterday. Let me tell you what we're doing tomorrow. Tomorrow we're gonna I'll tell you what we're doing tomorrow. No, you're good. Tomorrow we are going to live demo and unplug first to explain free response 2009 number 4, which is called, I'm going to call it wrong. It's called Number Tile, and that's the class that it sits on. And then the other file is called Tile Game, and it's a spinoff of Dominoes. So we're going to teach you kind of the premise of the game and then unpack and show you how to solve that free response from 2009. And so that's kind of what we're doing tomorrow. So that's why it's Fun and Games Week. And then Thursday, we're going right back to our cards and our decks. And hopefully by then you've built some amazing game that you're going to show us. So remember to share it. I'll look on Twitter, and I have some friends that do TikTok. So if you share what you're building at my CSA exam prep, we'd love to see it. Okay, let's see. We got 3 dogs for today. And so fun how the rainbow, like what was that, light diffraction or something
Yeah.
was hitting Roscoe's face. And anyway, 3 sweet
Oh,
dogs.
look at Birdie in the
I know.
middle.
I
Oh,
know.
who's
From
a good
coast, we
boy?
got coast to coast over here. Well, Buffalo's not exactly on the coast, but it's close enough.
Yep.
San Jose is definitely on the coast. And as usual, y'all, it's time for you to let College Board know if you need tech help. cb.org/tech, and do that today or soon. And we appreciate you being here with us. We held you a minute or so longer, but I promise it was worth it. So we hope to see you tomorrow for Free Response Day, and then more games.
Yep.
And
Stick with us this week.
Yeah.
It'll be fun.
See you tomorrow.
Yep. Everybody have a great day.